as a second wave of mobile laser scanning, some really, well, tough companies have developed their own versions of SLAM algorithms and developed their own products. Some of those we used yesterday, like the hover map of Yuri from Australia and the Zeb Horizon device, which they all use the same sensor usually, which is a Velodyne puck, the same one that Eben has in his drone. And they all use it for a simple reason, cost. It's the cheapest sensor in the market, but it's of course not the most precise one. But it can deliver very good results using those new versions of SLAM algorithms, in which you can really reconstruct not just globally coherent point clouds, but now locally coherent point clouds as well. Even though it might have some noise because the precision of the sensor is not as good as a Faro or a Rigo, you can really see the features there. And since the error is not biased, you have plus minus 2 centimeters, and the average of the errors is usually 0. You can measure things by taking the average of the surfaces you can see in the point cloud. And regarding logistics, it is much easier to operate because you don't have to put your scanner in several static positions across a plot, for example. You can just walk wherever you want, and then you can have full coverage on the 3D space of your forest. You can really target all the trees you want to measure, and it distributes the point density way better across the plot or across the landscape. You don't have much variation in this regard, and everything would be as probable to be found in a point cloud because the point density is more spread out. And well, some outcomes from our field survey yesterday is not as comprehensive as the analysis that Eben has done, but I was able to extract data from 3 scanning data sets. For the ones of you who haven't been to our field trip yesterday, we scanned 4 forest types with 7 setups. 2 photogrammetric setups, and the other ones are laser-based, 2 static laser scanning systems. One is from Rigo, with this new, really amazing, impressive technology. I'm not trying to advertise anything, but the point clouds we got from their systems are really amazing because they applied the new Rigo V's 400, and they don't need any targets on field to do the code registration. You can just put your sensors in several spots across a plot. As long as they are not very far from each other, you can do the code registration automatically without any targets. And the sensor precision is about the sensor accuracy is about 5 millimeters of point accuracy. So it's a really good description of the forest we have here. You can clearly see the branching structure, the holes inside the stems. We also tested several mobile laser systems. One of those was the Zeb Horizon scanner, which uses a Velodyne puck with an onboard SLAM system. And we can really get also great point clouds. But since the sensor is not as accurate as the Rigo sensor, for example, we have a bit more noisy point clouds in terms of thickness of the walls of the stems you are trying to measure, and a bit of noise around the leaves and the ground. But overall, it's a very good point cloud. You can really see and recognize the objects and the trees in there, and you can measure a lot of things inside of it. You can even segment the trees standing up to a certain point. We also used our own mobile system. It's custom made, it's homemade, and it's all based on open source software. And it was quite good. I was actually very happy and a little bit surprised that it was performing on all scenarios we scanned. And you got really good data of it as well. Of course, it's noisier than the professional closed systems, but you can have really good point clouds if you scan for getting the heights, for example. You can really see well the canopy structure and some branching structure from those point clouds, even though they are more noisy. They are very dense on the first horizontal layers of the forest because the sensor is not moving everywhere. It's scanning all the time 360 degrees sideways. And then you have a very dense point cloud closer to the DBH, up to 4 or 5 meters. And then you can really see well the lower structure of the trees, and you can measure DBH and lower diameters with a very accurate, very high accuracy and precision as well. So those are some short outcomes from yesterday, just so you know how does it look like to scan with a mobile laser system from the ground. And now some overview of how it works, because you have a lot of freedom with those sensors when you are scanning in the forest. because you don't have to position them statically anywhere. You can just start scanning and walk around. As long as you don't try to hammer anything with your sensor like this, it's going to work fine. And then you can trace back the whole path you did inside the forest and reconstruct everything from there. With a very good global and local consistency, very high, very accurate measurements you can deliver from those point clouds. And some benchmarking for MLS. Just so you know, the first studies regarding MLS applications for forests and for forested scenarios sprout on the last 3 years. And those used, I would say, the first wave of mobile laser systems, which did not have a very long range. You cannot see how tall the trees were because the sensors back then were not reaching the upper layers of the canopy, and the algorithms applied were self-developed or open source, and they were not as performant as the commercial devices we have now. So for a second wave of MLS, you have way better data and probably way better results as well. And regarding comparison with a terrestrial scanning setup, the results for dBH and height are pretty much the same. You don't have to buy a very expensive sensor to get your forest inventoried in a very precise manner. It works well on both ways. And those charts to the right of the slide here are a benchmark, a self-made benchmark. It is a database of more than 500 trees, eucalyptus trees on forest companies in Brazil. They were all scanned with our backpack, and we measure dBH and height of all trees in those plots. And well, the accuracy and precision we got from those scannings are very close to the literature. But our sampling universe had trees in between 5 and 20 centimeters, and more than 70% of those trees, in terms of error between the manual measurements and the laser automated measurements, were below 2 centimeters of average error, which is in the range of the sensor precision, accuracy actually. So those are very promising results. You can actually perform full forest inventories very quickly using mobile systems and extract pretty much the same results as you would measuring by hand. For height, it's pretty much the same outcome, but you have even higher accuracy and precision. I would actually trust more the height measurements we take from the laser inside the plantations at least than the ones we take by hand using the hypsometers or some of those instruments, because the error of those instruments are very dependent on the user, and sometimes you cannot really see the top of the trees and have a good estimate of it. With the laser, you can really see everything. If it's a quite open canopy and the trees are evenly spaced, more than 1.5 meters, you can really see well the top of the canopy from the terrestrial point clouds. So the height measurements are no problem at all. And well, some remarks regarding analyzing those noisier point clouds from mobile systems. There is no benchmark for volume measurement so far, but I have done some myself. This is an eucalyptus tree extracted from a ZEP Horizon scanner, and we were able to segment it up to 22 meters high. And there is some noise, of course. You might have some biases, especially upwards, because as the sensor tries to reach up the canopy, it is blocked by branches, the point density is lower, so it gets harder and harder to get diameters up in the canopy. But you can go up to certain heights, and after you apply some robust methods for smoothing your results, you can really have nice descriptions of the taper curve of the tree. And from those taper curves, we can deliver volume of standing trees without any harm to the operator and having to chop down the trees anymore. And well, before I jump into a more in-depth discussion about where we got and where are we going to, why do we use LiDAR and not some other technologies already available and much cheaper like photogrammetry to do forest inventories? I would say it's a matter of perspective, because the cameras, they cannot see very far when you are trying to extract a point cloud from the stereoscopy and photogrammetric systems. But LiDAR can. So you have the sensors like the Velodyne that has a range of 100 meters, which is way more than necessary when you're trying to measure a commercial forest plantation or even most of the tropical and natural forests. And then you can really see everything from the ground up to the high canopy using a single sensor in a very efficient manner, just walking by the forest or putting something else to walk for you in the forest. And while photogrammetry has a very limited range of of 3D reconstruction capacity. But they're really good if you're trying to measure something that is very well localized and has a limited surface that you can see from the top, like wood stacks and chopped down logs, and even the base of the trees. Although the fieldwork is more extensive because you have to walk around everything you want to measure, it just doesn't go shooting laser everywhere and gets you a point cloud of 100 meters radius. You have to walk and take photographs of everything you want to measure. It takes way more time, even though it's way cheaper, but it's not really replacing LiDAR anytime soon for applications that require a longer range of distances. And well, how operational is MLS then? After we saw all this benchmarking and data sets, this is a proposition by Liang, which is probably the biggest name in the TLS universe in forestry. This guy, he just publishes everything you know about TLS first, before everybody else. And this was his proposition, that we have 5 levels of difficulty when processing TLS data, from dBH and height up to stem segmentation, and then going through segmenting branches, twigs, and even lower canopy leaves and other types of plants. Up to now, I would say we have very good estimates and very good potential to fully replace forest inventory in a commercial scenario on the 2 first levels of difficulty, dBH and height, and taper curve, tree volume, and stem segmentation. And what can be done now in this regard? The SLAM algorithms, they show very good performance outdoors. The second wave of SLAM algorithms and mobile laser scanning devices, they are very performant outdoors in any environment you may think of. So you don't have drifting issues anymore. You have very consistent data sets. And the field work can really be replaced because it's much more convenient for you to walk with a laser scanner on your hand than just go taping and looking up in the forest all the time. And the operational post-processing for planted mature forests is already well established. The algorithms are good. It can be almost fully automated, but it still requires some really high-skilled personnel to post-analyze those results and correct anything that might go wrong. Because when you are scanning a single plot and try to extract the trees, okay, it's a tough job, but somebody can just follow it through and fine-tune all the parameters of the algorithms they are using to have the best possible outcome. 10 plots a day for 30 days in a row. There is no human that's going to have the energy to keep up with this work. You just have to automate as much as you can and just perform some double check by the end of the process. And what needs to be improved so we can actually implement and fully replace forest inventory as we know in the commercial plantations by the MLS or TLS systems? Well, we have to keep up with computer vision and artificial intelligence algorithms because every year we have new methods for robust cloud segmentation, extreme outlier rate, shape detection, cylinder detection, pattern recognition algorithms. So they're getting very sophisticated and much more performant in terms of computer power and accuracy of the results and how much time you need to operate and deliver information from data sets in 3D. The algorithms and especially the methods for measuring and inventorying the forest, they should be more available. You barely have any software there that automates this process for you, and everything that is published, sometimes it's open source, but if you want to use it, you gotta be a very skilled programmer and have a really good idea of the statistical methods that are lying down there, because you have to parameterize everything. And the parameterization of those algorithms is not so easy, and it changes depending on the type of forest you scan, the age of the trees, how evenly spaced they are. So you really need to know a lot about a lot of topics to be able to use efficiently the tools available today. And what needs to be changed so we can get there? Well, the mindset for sure. We have to replace old standards or at least start to rethink it. If we have such high density, high resolution data, why are you still sticking to height and dBH? We can measure other stuff. We can measure way better parameters like first log volume as an indication of full forest volume, because you're not trying to estimate one variable after the other in a chain of errors. Now you can extract actual volume from the trees and trying to use it as a first input to estimate the whole volume or the whole biomass in your whole forest. And besides that, you can rethink of statistical designs because you can just walk in the forest in a large transect. You can really scan heavily one single tree every certain distance and get the full volume of those trees and maybe extrapolate those volumes to the whole area instead of measuring plots just like we've been doing forever. And well, in terms of education, we should really prepare the foresters who are coming to business and to academia right now. Everybody should know a bit of data science and data mining and some programming. We don't have to be experts, but you should be able to manage those quite well in order to get into the new world that's coming. And it's actually already here. Everything is data-driven nowadays, and forestry is not different. And to overcome the traditional values. Some people really, they have really hard mindsets. It's really hard to convince them that the technology works. And even if it doesn't work right now, it's very promising. And people need to understand it's a working process. We should be able to integrate better academics and the operations and computer scientists and foresters to bring together all this package of solutions and brains to develop and put forward a robust, full framework for replacing forest inventory. That's just an idea, but I'm trying hard to work on this by myself. And well, before we finish, some future perspectives. 3D inventory will take over eventually. It could be with automatic processing of terrestrial laser scanning point clouds. It could be by UAV measurements, like Eben is trying very hard to do it, by densifying the point clouds and getting dBH and diameter estimates from aerial point clouds, or even from augmented reality technologies in which you can just walk inside the point cloud from your home or your office. Well, you are still in the forest. It's a digital 3D forest, but you don't have any risks anymore. You don't have to chop down the trees. You can just jump, and you are on top of the tree measuring something. The point clouds will be commoditized soon because it's not only foresters who are in need and are using it. Agriculture uses it, infrastructure uses it, architecture, engineering, pretty much any field is using point clouds to do something. So the devices are getting cheaper, they're getting more available, they're getting more portable, and everybody will be able to buy a laser scanner in the next years by a very cheap price. So the methods should keep up with the hardware because the hardware and the data sets are much more advanced than the methods and the algorithms we have to process and extract useful information from those. So the hardware and the data sets are pretty safe, but you have to step up in terms of software and methodology optimization. Everything will be probably robotized and in the near future. And the computational efficiency is just getting better. You can process everything in the cloud. The connection is getting faster and faster, and we don't have to worry about transmitting your data sets from anywhere in a few years. So that's what I had to say. Thank you very much for your time, and I hope you enjoyed it.